Welcome everyone. My name is Sai Rani from Pinoris Academy of Management and Technology, Ratnagiri. My team partners are Sahil Jadhav and Prathamesh Naik, and we are proud to got a guide of Dr. Nitin Kansi sir. Our project presentation on experimental study of air cool and helical coil heat exchanger. These are the content we have taken in our PPT. The first is introduction. We all of you know the principle of heat exchanger based on the second law of thermodynamics. The heat exchanger is a device designed to efficiently transfer or exchange heat from one fluid to another fluid that are at a different temperature. The fluid could be liquid or gas such as a moving air. The various heat exchange operations carried out in chemical process plant are one, heating and cooling without phase change involve insensible heat transfer. Second is boiling and vaporization of liquid to vapor, and third is condensation of vapors involving phase change. And type of heat exchanger. First is air cool heat exchanger. In this type of heat exchanger, purpose of air is used as a coolant. This type of heat exchanger commonly used in industrial application. Even if water is available, in some cases air is cool. Heat exchanger are economic or operational reason. Air cool heat exchanger throughout the entire oil and gas industry from upstream production to refinery and petrochemical plants. Air cooled steam condenser are special type heat exchanger employed to condense steam at exhaust end turbine for the both power generation and mechanical drive application. Then second one is a water cool heat exchanger. Water cool heat exchanger have two independent circuit, one for process and one for service media. They work by removing unwanted heat from process to transfer it to service. The water cool heat exchanger is more efficient in transferring or removing unwanted heat from one to next media as compared to air cool. Then advantages of water cool heat exchanger. The first advantage is process fluid can be cooled up to 5 to 8 degrees centigrade lower than air temperature. Second advantage is water cooling require less heat transfer area, and third advantage is water cool is less susceptible to temperature variation. Then disadvantages. First, water supply is scarce and it has to be pumped from long distance through a pipeline or well. It require cost. Second is site for large plant depend upon the source of water cooling. And third disadvantage is the water causes corrosion and water treatment is necessary to prevent fouling of surface. And literature survey. H. Sokumad, M.R. Salimpur and M.A. Akshavan Behwadi study on experimental investigation of shell and coil tube heat exchanger using Wilson plot. The overall heat transfer coefficient of the heat exchanger were calculated using Wilson plot. Then M. Mohammed, study on experimental study of force convection from helical coil tube with different parameter. And the experimental result indicate that these parameters have important effect on average heat transfer coefficient. The average Nusselt number increases with increases in diameter ratio at constant Reynolds number and P by D means pulse ratio. Also increases with the increases of P by D ratio at a constant Reynolds number and diameter ratio. Then Nazar Gorbani and Hassan Terrain study on experimental study of thermal performance of shell and coil heat exchanger, and in the present study experimental investigation of mixed convection heat transfer in coil and shell heat exchanger is reported for various Reynolds and Rayleigh numbers, and it was found that mass flow rate of tube side to shell side ratio was effective on the axial temperature profile of heat exchanger.
So, in materials and methods, I am going to explain shell and tube heat exchanger first, then I will explain helical coil heat exchanger, shell and tube heat exchanger. For varieties of industrial service where large heat transfer surface are required, shell and tube heat exchanger are commonly used. This heat exchanger equipment can be fabricated from a wide range of materials of construction. The design of shell and tube heat exchanger. A shell and tube heat exchanger consists of a number of parallel tubes, end of which are mounted in the tube sheets, and the entire tube bundles is included in close-fitting cylindrical shell. In this exchanger, heat transfer surface is the one that is provided by tubes. One of the fluid flow through the tube and is called tube side fluid, while the other fluid which flow through the space created between tubes and shell, that is outside the tube, is called as shell side fluid. The process fluid assessment to shell side or tube side. The selection of stream temperature specification. The setting shell side and tube side pressure drop design limits. The setting shell side and tube side velocity limits. The selection of heat transfer models for falling coefficient for shell side and tube side. The mechanical of shell and tube heat exchanger. The selection of heat exchanger, TEMA layout and numbers of passes. The specification of heat parameters, size, layout, pitch and materials. The settings upper and lower design limits on tube length. The specification of shell side parameters, the material, buffer cut, buffer spacing and clearances. The setting upper and lower design limits on shell diameter, buffer cut and buffer spacing. The second point is helical coil heat exchanger. Helical coil units commonly are used as interchanger, preheater, steam condenser, vacuum system inter and after condenser, reboiler, batch heaters, and cooler and reactor jacket coolers. The exchanger also are suitable for less demanding applications such as heat recovery, condensing, boiling, and basic heat exchanger. The advantages: compact size provided distinct benefits. The higher fin coefficient, the rate at which heat transfer through a wall from one fluid to another. More effective use of available pressure drop result efficient and less expensive design. The limitation: there are very few limitations for the use of helical coil heat exchanger. Generally, a pressure limits of 10,000 psig cover the majority. For application of temperature limits are determined by construction material as are the correction rates. The surface area of 1 to 650 square feet are available, and using units in series or parallel may extend this range substantially. Now Prathamesh Naik is going to present from next slide.
Experimental work. Preliminary design. PVC materials are lightweight, inexpensive, resistant to corrosion, and easy to maintain. That's why apparatus used in original design are PVC. The helical coil is housed in a 20-liter plastic bucket. The thermal characteristics of plastic were considered as hot water is being used. Water was chosen as the working fluid for both the hot side and the cold side for safety reasons. In the final design, for the final design, copper tubing and brass fittings were chosen. We housed the helical coil in a 20-liter plastic bucket. We mounted a spiral coil, air-cooled coil on the utility cart. A fan having a 2200 RPM is fixed exactly below air-cooled coil, and a small mesh size net is provided on the air-cooled coil as a fins. The inlet of this air-cooled coil is joined to the geyser through which hot water is passed, and outlet of this coil is directly attached to the helical coil inlet for ease of convenient. Apparatus. We used helical coil, pump, air-cooled spiral coil and geyser. The specifications are: air-cooled spiral coil length is 400 cm, helical coil length is 917.5 cm, diameter of helical coil is 1.27 cm, spacing between each turn is 7 cm, and number of turns are 5. The helical coil. This is the main component in our apparatus. The helical coil is the focus of the heat exchanger. Our apparatus will be unique in this aspect. The pump. The pump which we used have specifications of 240 volts, 50 Hz, 0.18 kW per 0.25 horsepower, 1.48 amperes, 2700 RPM, head of 18 meter. Air-cooled spiral coil. Air-cooled heat exchanger include a tube bundles which generally has spiral wound fins upon the tubes and a fan which moves air across the tube and provided with a driver. Procedures. In this setup, the water is pumped from the tank to the geyser for the heating purpose. The hot water is then pumped through the spiral air-cooled coil. Then the outlet of air-cooled coil is directly attached to inlet of helical coil. The water is passed through the number of turns of coil which provide cooling effect to the water. Water is also cooled by cooling water which is passing through shell. The water gets cooled and comes out through the outlet. Temperature drops in each coil and shell side outlet is recorded with the help of thermocouples. The temperature is shown by digital screen within every 2 minutes of interval. In this experiment, we measure temperature drop for 4 different shell side and tube side mass flow rates. Observation: we took 2 runs. In run number 1, we took tube side mass flow rate is 0.054 kg per second and shell side mass flow rate as 0.059 kg per second. And in second run, we took tube side mass flow rate 0.0582 kg per second and shell side mass flow rate as 0.0905 kg per second. Result and discussion. A test run was completed on the apparatus. Once all the components were in place, the system was checked thoroughly for leaks. After fixing the leaks, the apparatus was prepared for testing. Data was recorded every 5 minutes until the apparatus reached steady state. The hot temperatures fell as expected. The cold temperatures seemed to be more unpredictable, in one instance rising 6 degrees in 5 minutes and then on the next reading falling 3 degrees. For each run, we got steady readings of helical coil heat exchanger. Conclusion: helical coil tube allows the fluid to be in contact for greater period of time so that there is an enhanced heat transfer compared to that of the straight tube. The best way to avoid particulate falling is to keep the cooling water clean and thereby prevent particles from entering the heat exchanger. Fouling factor is numerically allowance for possible coating of the tubes by dirt. It is occur inside the tube or outside the tube. References: we used some books by McGraw-Hill. Also, we took some information from the internet. Thank you.